Welcome to Study Loop.
We're going to be using some simple relationships in electricity that relate energy, potential energy, to potential as well as electric field in order to find an unknown electric field vector. So we have a single charge sitting in this uniform electric field. And the basic definitions that we're going to look at are as follows. We have electric potential is related to the work done by the field with a negative sign. They are equal to each other with the negative sign. In other words, if the field does positive work, that means the potential dropped, potential energy dropped. The other relationship is between potential and potential energy. Potential is a single object by itself, like an electric field having a potential difference, whereas potential energy is an interaction between two things. And finally, the other relationship we will need is that the electric field is the gradient of potential, which means how potential changes spatially over a spatial distance. And here, I'll just be interested in a magnitude, but in reality, that gradient would have a negative sign sitting in front of it to relate to the electric field. Like I said, I'll worry about the sign in a different way. Okay, so what we know about this charge is that it started from rest and acquired a kinetic energy of 2.2 times 10 to the minus 6 joules through conservation of energy. We know that the change in kinetic plus the change in potential energy, those both have to add up to 0. So the fact that the kinetic energy was positive means that the potential energy of the system dropped by the same amount. Okay, and what that tells us then is that since the delta U was negative, the field, the electric field, did work. Exactly opposite that amount. So the work was positive. And that makes a lot of sense. The charge would actually be pushed to the left along with the electric field. And therefore, the force would be impelling the charge in the direction of its displacement. Okay, and now we can find the potential drop. Delta V is equal to delta U over Q is minus 2.20 times 10 to the minus 6 joules over the charge plus 4.2 times 10 to the minus 9 coulombs. And that is minus 524 volts. Okay, so yes, the potential drops in going from a place of positive electric field to lower. If we thought about the charges creating that electric field, they would be more positive to the right and more negative to the left. We don't know where those charges are, but that's kind of the picture. So the potential is dropping. And now how do we find the electric field? We will simply take the magnitude of the potential change over the distance the particle fell, which was 0.06 meters. And that comes out to 8,730 volts per meter.